Network topology refers to how various elements of a network are combined to form a functioning network. A synonym to network topology is network architecture, which refers to how various network elements or devices are put together, just to reiterate what I just said in the introduction. The ultimate goal here is, of course, to form a functioning computer network. Network topology is a physical layer concept. Therefore, the elements we're talking about here include things such as wires and devices. The devices include things like switches, routers, and computers. There are different types of network topologies, including point-to-point, star, extended star, mesh, and bus topologies. Point-to-point is one of the simplest network topologies, and as you can see in the diagram, point-to-point connects these two hosts, host 1 and host 2, using a network connection. Star topology typically involves a switch at the center. Other devices are also connected to the switch in this topology. So these other devices are typically any hosts that need to be connected to the network. In the star topology, the network traffic always goes through the switch at the center, namely at the center of the star. Therefore, there is only one path between two hosts at any given time. In this topology, the switch is what enables the connection between all the hosts involved in the communication. One thing to remember here is this is different from broadcasting because the switch in this case only connects the hosts that desire to get connected to each other. So when, for example, host 1 wants to send a message to host 2, the only devices involved in the communication are the hosts themselves and the switch. In the broadcasting scenario, every single device connected in the network get notified or get the messages. When everything is said and done, this is what the star topology actually looks like. An extended star topology is a collection of star topologies. It still provides a single path between hosts, but the only difference here is the extended star topology represents a hierarchy of switches, as you can see here. For example, switch 1 is now connected to switch 2, and then switch 3 is connected to switch 2. When you're just setting up a single network, all you need is a switch, and the switch and the host connected to the switch forms a star topology, as we already discussed. One of the problems with the star topology was this possibility of a single point of failure, although the possibility is pretty low. When these individual networks are connected, they form the internet, or lowercase I internet, which simply means a collection of individual networks. So the uppercase I internet means the internet, also known as the World Wide Web. So to connect these individual networks to form the internet, we use a device called router. And since we're talking about now millions and billions of individual networks being connected, there could be many things that may go wrong. Therefore, in this case, the stakes are much, much higher, and we need some redundancies, and this is why we need a mesh topology. Basically, the difference between the star topology and the mesh topology here is that in the mesh topology, there are multiple paths existing between the hosts, unlike what you're seeing in the star topology. And here is a diagram of mesh topology, and as you can see, in between the two hosts, you can have more than one possible connections. Therefore, even one of the connections fails, you still have a way to get to the host you want to reach. Bus topology depends on broadcasting. Some of the network devices using the bus topology include wireless access points and hubs. Compared to switches, hubs are not very efficient because every time you have something to send to a specific host, you have to send it to all the hosts in the network. So that's one of the reasons why hubs are no longer used and replaced by switches.